Okay, so today I want to talk about the decimation cipher. The decimation cipher is another crypto system that we can use to try to take messages and turn them into something that is incomprehensible to some third party who's trying to intercept the message. So decimation cipher. The decimation cipher is a lot like the Caesar cipher in that you're taking the letters and you're turning them into other letters. But the way that we're going to do this is instead of adding a shift, we're going to multiply by what's called a key. So to encrypt, you multiply the number associated to the letter by a key. So it's really not half bad. Basically, you take whatever word you want to work with. So maybe we want to work with today. And we want to encrypt maybe with a key of 3. Or let's do a key of 5 instead, just to jazz it up a little bit. So today, T is 19, O is 14, D is 3, A is 0, and Y is 24. So we're going to multiply by 5, so we get 95, and then we get 70, 15, 0, and 120. We got to get these things back in range, so we're going to subtract multiples of 26. So here I've got to subtract 26 a few times. In fact, I've got to subtract it 3 times. And when I subtract 26 3 times, I'm really subtracting 78. Okay. And so what I end up getting is I get, let's see here, 217. And then 70 I got to subtract 52, which is a multiple of 26. And I end up getting 18. Sorry, 8. And then 15 is okay. And 0 is okay. And 120 I'm going to subtract 104, which is also a multiple of 26, and I end up getting 16. Now these correspond to the letters, 17 which is R, 18 which is S, 15 which is P, 0 which is A, and 16 which is Q. So for encryption for decimation cipher, not half bad. You're essentially just doing what you did for Caesar cipher, but instead of adding a shift, you're multiplying by a key. And a key is just a number. There are specific keys that we're allowed to use, and we'll see why in just a second. But that's all you got to do for encryption. Take the letter, find its associated number, multiply by the key. So here I'm multiplying by 5. And then just like the Caesar cipher, get it back in range if you've gone too large. So here I'm subtracting multiples of 26. Get a number between 0 and 25, and then find the associated letter. But what about decryption? How do you decrypt? If you're thinking about the way that we decrypt for Caesar cipher, you might say, oh, just divide. But there's an issue with that. So if I go to R, S, P, A, Q, and I write down their letters, 17, 18, let's see, P would be 15, 0, and Q is 16. I would like to divide by my key, divide by 5. But if I take 17 divided by 5, so if I divide by 5, I actually get 3.4. And for the life of me, I'm not going to be able to look up on this list and find 3.4. There is no letter associated with 3.4. So I've got to do something slightly different. So when you're decrypting, what it turns out is that the reason we can't, because we're really talking about doing these, subtracting these multiples of 26, getting back into range. And if we get back into range, it kind of screws things up. And in fact, what we're really using is we're using what's called modular arithmetic. And we're not going to go into too much detail, but this idea is that essentially, if you count two numbers, say 53 and 27, If you count these numbers starting at 0, so 1, 2, 3, all the way up to 25, 26, 27, that will land at B, or 1. And if you did the same thing and counted 53 by going back through the alphabet, you would also land at B, or 1. So it turns out that these two numbers are kind of seen as the same. And so when we're talking about modular arithmetic, there's a different thing that you can do besides dividing. Trying to divide by 5 is not going to work. What you can do instead is multiply by what would be the inverse, or kind of like the reciprocal when you're talking about multiplication. The inverse for a key is what we call the decryption value. So for each key that we're allowed to use, we have a decryption value. So let's see. So to decrypt, you're going to multiply by the decryption value. So the keys are allowed to be the numbers, the key and then the decryption value. You can have a key of 3 or 5. You can have a key of 7 or 9 or 11. You can have a key of 15 or 17. You could have a key of 19, 21, 23, and 25. And for each of these, they have a decryption value. The decryption value for 3 is 9, for 5 is 21, the decryption value for 7 is 15, for 9 is 3, for 11 it's 19, for 15 it's 7, for 17 it's 23, for 19 it's 11, for 21 it's 5, for 23 it's 17, and for 25 it's 25. So what you're going to do instead is you're going to find, so because this was encrypted with a key of 5, you're going to find the associated decryption value. So you're going to go down, the key was 5, the decryption value is 21, and you're going to multiply by it. So we're going to multiply by 21 by each of these numbers to get the associated, the new number that we're trying to get for decryption purposes. So now we're starting to get a little bit larger, so let me grab my calculator. So I'll take 17 and I'll multiply it by 21, and I get 357. 18 times 21 gives me 378. 15 times 21 gives me 315. 0 times 21 gives me 0, and 16 times 21 gives me 336. Alright, so this right here is the decimation decryption. Now we just have to get back into range. So I'm going to take my 357 and I'm going to subtract multiples of 226. I'm going to subtract 260, I'm going to subtract 52, I'm going to subtract 26, and I get all the way back down to 19. So I'm getting back into range by subtracting multiples of 26. 378, I'll do the same thing, minus 260, minus 104, I get 14. 315 minus 260. Now I can't subtract any multiple of 26 because essentially I'm just subtracting 26 multiple times. So I get down to 3. 0 is already in range, and 336 minus 260 minus 52, and I get 24. Then find the associated letters, T, O, D, A, Y. And amazingly, multiplying by the decryption value gives me back to where I started. In other words, it actually decrypts my gobbledygook message. That's the decimation cipher. Right? To encrypt, we multiply by the key. To decrypt, we multiply by the decryption value. Now suppose I had started instead by taking some word and I encrypted using a key of 3. So I multiplied each number associated to the letters by 3. When I decrypt, I'm going to multiply by 9 because that's the decryption value. So that's how the decryption values work. If you encrypt with an 11, you decrypt with a 19. But it's always multiplication. There's no division involved. The last cipher I want to talk about is called the linear cipher. And I'm going to leave the key and the decryption values up here because we kind of need them. So let's get rid of the rest of it. So the linear cipher. The linear cipher is a combination of both the decimation cipher and the Caesar cipher. Okay, so how does the linear cipher work? The linear cipher works by multiplying by the decryption value, the linear cipher works by multiplying by the key and then adding the shift. So when you encrypt, encrypt, multiply by key, then add shift. So example, suppose we want to use a key of 3 and a shift of 2, and we want to encrypt, let's say we encrypt let's say, who knows, let's do math. Well, then I'm going to do the exact same thing I've done before. So 12 for M, 0 for A, 19 for T, and H is a 7. Now I'm going to multiply by my key, so multiply by 3 and I get 36, 0, 57, 21. I'm going to add my shift, so I get 38, 2, 59, 23. And then I'm going to get back into range, so I'm going to subtract 26, and that gives me 12. 2 is already in range. 59 subtract 52, and I get 7. And 23 is already in range. And then I'm going to find the associated letters. 12 goes with M. 2 goes with C. 7 goes with H. And 23 goes with X. So math, when encrypted using the linear cipher, key 3 and shift 2, gives you MCHX. But what about to decrypt? Well, think about it like this. Imagine you're wrapping a present to give to somebody. You put it in a box, then you wrap it in wrapping paper. Now you give it to that person. How do they undo the wrapping? How do they find out what gift you're giving them? Well, you have to undo it in the reverse order. You put it in the box and then wrapped it in paper. They need to unwrap the paper and then take it out of the box. Think about what we did for this encryption. We multiplied by the key and then we added the shift. We need to decrypt it. We need to go in reverse order. So we need to subtract the shift and then undo the key, or multiply by the decryption value. So suppose I start out with MCHX. MCHX. And now I'm going to decrypt. Well, M is a 12, C is 2, H is 7, X is 23. And I'm going to decrypt. So I'm going to shift, I need to subtract the 2. So 10, 0, 5, 21. And then I need to undo the key. Now I don't just divide by 3, and I don't multiply by 3. I'm undoing the key. So I need to multiply by its associated decryption value. So I go up here, key is 3, decryption value is 9. So I'm going to multiply by 9. So I get 90, 0, 45, and 189. Now I need to get back into range. So I take 90 and I subtract multiple of 26, and I end up getting 12. 0 is already in range. 45, subtract multiples of 26, and I get 19. 189, and subtract multiples of 26, and I get 7. 12 corresponds to M. 0 is A. 19 is T. And 7 is H. And again, just like you kind of expect, when you encrypt and then decrypt, you get back to where you started. And we started with math, and we ended with math. So, to sum up all the crypto systems we've talked about completely, Caesar cipher, to encrypt you add a shift, you subtract the shift to decrypt. Decimation cipher, you multiply by the key to encrypt, you multiply by the decryption value to decrypt. In linear cipher, you multiply by the key, and then add the shift to encrypt, you subtract the shift, and then multiply the decryption value to decrypt. Good.